Yeah, so what I'm saying, so we're going live. Hello, YouTube. So the samples of Osh Park from last week, turns out I didn't have enough SMA connectors to stuff it. So I've ordered them from DigiKey, the SMA connectors.
Okay. So we'll get to check that out on a future episode.
We will. But you have some Osh Park samples to show us today, and we'll get to those here in a little bit.
I do. I'm just not seeing that we're live yet.
I'm seeing that it's live. Are we in the right place? I know we're in the right place.
Well, that's a question on the CoriolisEffect.com.
Okay, we've got, hey, you're live. Wes says we're live. Hi, Wes.
We're live. Hi, Wes. Cool. I can't see it.
All right, now I'm seeing concurrent viewers starting to kick on. There, they see. John says he can see us. I'm hoping he can hear us as well. All righty. Dave also confirms we're live.
Awesome. I just need that link so I can post it. Why am I not seeing it? That's weird. Just some additional delay, I guess.
Sounds broken, actually. Do you hit refresh or something?
Now I see it. Thank you. Refresh did the trick. That shouldn't be the case, but whatever.
Right. It should be stateless, but.
Okay. Well, I'm going to close that so I don't get any echo. But I got the link now, so I'm just posting.
All righty. Rock and roll. It's like the episode of Spinal Tap where they get lost and they keep trying to keep amped up and they're like, woo, rock and roll, yeah. And they're walking around an Air Force base. Hey, so did I ever tell you why I didn't get into Doctor Who? I know you're a Doctor Who fan. Oh, by the way, somebody asked in the chat one time if we were, hey, Mike, how you doing? They asked if I was a Trek fan. And one thing I'll say is I saw 3 Star Treks when they were originally being aired back in whatever, the 60s or whenever. I saw 3 episodes live. So that was before DVRs and we had to wait years for reruns to come out. So, yeah. But the reason I never got into Doctor Who was just bad timing. One, I didn't like the Daleks, whatever they were called. And they had an annoying voice, and I'm like, oh, I could kick their ass, so I turned to a different channel. I just knock them over, right? And then I just happened to be with the guy with the big long scarf and everything, and he defeated somebody by some piece of junk he had in his coat pocket, and he says, I never throw anything away, and then he threw it away. And I didn't realize that was the cynicism built into the show at the time. But actually, you just froze up right on schedule. There, you're back.
Yeah, I did, or you did, or it was probably me.
It happens right about 5 minutes after the hour. That's why I thought it was maybe somebody streaming from your place, but it could just be AT&T again.
I think it's
hey, somebody's in Germany.
Anyway.
Hello, everybody. Yeah. Anyway.
Hey, welcome everyone. So cool. So you can see the chat on the tubes. I've got the. I'm open on
Discord.
On Discord. Yep. So.
Yep.
Yeah. Let's do this. Sorry, as you're saying, Doctor Who versus Trek. I don't know if it's a versus. For me, there's Star Wars.
Oh, it's
Trek,
not a versus. Yeah.
And there's Doctor Who. And Doctor Who was good because it was the low-budget poor cousin of Star Trek. And Star Trek was the low-budget poor cousin of Star Wars.
So I did see the Doctor Who's with Dave Tennant, and I liked those. But then when they changed the Doctor Who, I had to recalibrate, as everybody did. But not being a Who fan, yeah, I was like,
every time we regenerated. But my favorite.
Isn't there a woman Doctor Who now?
The what?
Isn't there a female Doctor Who now? Didn't they recast her? Cast it?
I think there is. Yeah.
That's
would
cool.
have had to have been by now.
Yeah.
Let's be honest. It's 2020. By now they've had everything. Doctor Who started in I want to say it was 64 or 67, somewhere around there. It was a long time ago. It was black and white, and I think
I was in high school.
The first episode ever was the Doctor goes back in time on Earth and meets cavemen, and they've lost fire, and they're really
lost the recipe, huh?
They've lost a person, or someone died who knew how to make the fire, and they've been living. They've regressed in their living. They were advancing, and then they regressed, and so he sort of shows them as if he's some sort of mysterious prophet. He doesn't do it directly. He doesn't tell them what to do. He just sort of leads them down a path of discovery so that they rediscover it, and then they start cooking again, and eating meat. So
right. And the appendix starts to atrophy after that.
Right, yeah, because I think rabbits are the only mammals left that actually use it. Anyway, I could be wrong.
Supposedly, can't you starve to death eating just rabbit? It's like celery. There's not enough nutrients to justify the...
Probably.
Yeah.
Have you ever eaten
hey,
rabbit?
so... I have. I think I've eaten in Japan, they actually served me horse, and they brought out a plate one time, and they were all like, "Oh, for you, Bisan," and it was whale. And I was mortified. I told him, I said, "I'm sorry. We Yanks do not eat whale. I'm sorry." And that plate had to cost him hundreds of dollars.
Wow.
And so, in deference to me, nobody else ate it. But even though the whale's already dead, but I that was the one place. I even tried the crunchy sparrow, which was basically sparrow embryos. They were duck embryos or something in an egg, and we tried it, but I wouldn't eat the whale. So.
Yeah.
Just slight cultural differences. And it was the 70s, too. Hey, so I got something to show you, dude.
Yeah,
This
cool.
is the original conversation you and me had. By the way me and Ben met, or Ben and I, however you say it, was I missed his Hackaday hack chat. And Sophie was good enough to get you and me hooked up, so we started talking. And one thing led to another from there. But so it was indirectly through hack chat that we met.
Yep.
And you were talking about routers and Altium in general and things like that. But you talked about the auto routers during that time.
Yeah, I was running Circuit Maker back then.
Okay.
As a kind of new product launch, and there was a lot of, I don't know, I guess I'd been in touch with the Hackaday folks, and Sophie, I hope you're watching this and enjoying it, but thank you for making this connection. Because Bill's a good friend, and we'll never look back. It's one of those life moments where you meet someone who's really awesome and radical like Bill. So,
and one thing led to another. Yep.
Yeah. So here we are, and well, I was talking about topological auto routing because there's always a 50-50 divide, and we can see this even this morning in our Discord. The topic came up, and it's like there's people who will say, I don't use auto routers. And people say, well, I use them all the time. And it's kind of half and half of the PCB design community or hardware design community. I'm somewhere right in the middle. I think.
Right. So am I.
It's like there are things I will absolutely always do by hand. So those are going to be
power and ground grid, things like that.
Exactly, sensitive analog stuff. There's things I like to have some user-guided automation. So that's going to be things like memory buses and digital. And then there are some things where it's like Yeah, it doesn't have to look pretty. It just needs to work.
Right.
And there's a lot of designs like that, and I will certainly use an autorouter. But I think autorouters can help you lay out the board better too. I think they can be a good guidance tool with regards to part
Right.
placement.
Right. Right. Show you how well it routes, by machine, and if you can go back later and either clean it up or start fresh, but it shows you your routing channels.
Yep.
And whether you need to rotate a part or even 45 degree it or something.
Yeah, and I think, excuse me, I think we're at a stage finally after all these years. The semiconductor people have been using auto routing.
Oh, absolutely.
20, 30 for more than 30 years because they had to. Like with VLSI, the designs got so big and complex you couldn't. So you talk about the stories when you were at MOS, and the layout people back then at first were taping everything up, right? Just like PCB designers did.
Rubylith. They were cutting Rubylith.
It's crazy, man.
They had just stopped when I got there, but the table, they still had light tables and they still had the Rubylith rolls of it in the corners and stuff.
They probably wanted to use up their stock of Rubylith rolls, and then we'll use all that up first, and then when we're out of that, then we'll look at computer-aided design.
Yeah.
I'm kidding. I had no idea.
No, there was one guy who was still like, hand tailored, and we're like, no, dude, if we can not hand tailor, it's a good day. So,
but it's like, let's be real. Some designs are so big and hairy and hard. If you could have automation and you could be okay with the job that the automation does, you'd use it, right?
Well, you know what opened the door for the auto routing then too was when we started, we didn't have comprehensive electrical rule checks and design rule checks that integrated to each other. So we didn't know if a delay from routing the signal wrong was going to hurt it or not. So we had to hand tailor it because we're kind of hand DRC-ing it, We're
right.
They're typing it into a simulation based on how they think the layout adds to it. So
yeah, that's actually super important. So basically, auto routers kind of did a good job, even as far back as Cooper and Chan, and the shape-based auto routing that divides the board up into rectangular.
Okay.
But the problem was it just had no comprehensive DRC or design rules configuration awareness. And even I remember the complaints back when I started getting into the EDA industry, and as an employee of an EDA company, it's people like, oh, I never use that. Why? Well, because it makes, and to Unix 2816's point in the Discord, and it's a good point, these things would run like power traces right next to sensitive signal traces, or just they did basically back then had no concept of the actual electrical aspects of design. They would just join the dots,
right?
And they did crazy things like put vias almost on top of each other,
go around someplace. Yeah. I've seen them send a trace all the way to the edge just to bring it back to go like a couple tenths of an inch, things like that.
Right, but I think and they were like that for a long time. I think it's come a lot further than that now. I think they're now much better than they were. But it's also because what designers want, that us EDA vendors have built automation into the routing, but we've also kind of made it more user guided and more touchy.
Right.
Because that seems to be more what people actually wanted, So.
Right.
So what are you showing me there?
Though I was going to say one of the secrets then, and you said this first, was to have a good default bunch of settings. If you can just turn it on and get something that works 70% of the way with the default settings, you're doing good, as opposed to starting from bad defaults where you have to tell it what a square is.
Yeah, actually, that was something I noticed. It's like spice simulation. It has a similar issue. Engineers love to simulate stuff because it confirms you know what you're doing, but it also saves time because you don't have to build hardware over
Right.
and
Lost
over
you.
again. Simulation front ends that were out there. Hey, am I back?
You're back. Yep.
Hello, I'm back.
Yep.
The problem with most spice simulation front end circuit simulators that I've ever looked at for the longest time, and again, this is something that's kind of changed in more recent versions, but is that there was no good defaults, and you'd wire up a whole circuit and spend 2 hours drawing your amplifier or filter, whatever it is. Then you'd go to simulate and it wouldn't converge because all the initial conditions and initial parameters for running a simulation weren't suitable for that design. They were just some sort of factory default that,
Right.
same problem. Your starting settings or your starting point, it's like you have to, back then you had to really read the manual and understand what each parameter was for, what it meant, and some of the mathematics behind them in order to reconfigure it for each different design you wanted to simulate. And autorouters are kind of the same. The initial conditions and parameters and design rules had to be set up, and I found that out of the box for a long time. I know this certainly was the case with Protel and Altium when I was there, that and I think it's changed since then too, but the default design rule set and the default router configurations was perfect for a through-hole or SMD board with 2 layers only, and with package sizes no smaller than an SOIC 8.
Okay.
And I found with those kinds of basic designs in digital, 2 layers, no ground or power planes or anything fancy, it would route to 100% completion and do a decent job. But I was sitting there thinking, no one designs boards like this now. Most of them are far more complex, right? So
Right.
anyway, I'm talking way too much. I'm sorry, Bill.
No, it's because
showing something interesting there. This is a tool I am not actually familiar with at all. So why don't you show us what we're looking at here?
Alrighty. So hang on, I got to bring it to the very top. Here we go. So this is Proteus, which I used after National, but before Altium. And this is an FPGA board that I did. I happen to brand it with Hackaday. And one of the reasons why I did auto routers back when I was doing Hackaday, I was doing a Hackaday video every 2 to 3 weeks. And it took me a month to have something done and ready in the queue. So, and then it'd be on the screen for 3 minutes and then never used again. So that's perfect for auto routing. All I had to do was work once. So this is Proteus, and if I go over here, and so there's a 144 pin Cyclone FPGA. There's level shifters here and here, and then some through hole. Oh, this actually fits an AT Mega board. So this was a shield for an AT Mega that
cool.
could be used as a logic analyzer. So there was a ribbon cable for your signals here, and then this plugged into the AT Mega headers, and these are also AT headers here. So I'm just going to go ahead while I'm talking. I'm going to tell it tools, auto route.
Now you've previously configured all your design rules, and
no, this is out of the box. This is
really?
Out of the box. Yep. So I'm going to begin routing, and it's 28 seconds after the minute here, and I'll just keep talking while it's doing it. But the downside of it is I don't know that you can program a whole lot of things. It's certainly not like Altium, where you can tell it about anything you want to tell it about, whether it's room-based or whatnot. But let's see if I can get a little more of what's the activity, because down at the bottom, it tells us how we're doing. So it's on pass 2 of 50. And excuse me, and I should say, this is running on my laptop. This isn't even a hopped up computer. This is just a laptop that's running. And we're coming up to 10 seconds after the minute.
I'm seeing a lot of vias being popped in there, and I'm also seeing. Okay, so it's doing a number of different passes.
Right, it'll do up to 50.
Things, right?
Now, I had just run this and it took less than a minute, but now the conflicts are down to 5, 4, 3, 1, and so it's effectively done, and it's going to start a cleanup pass.
Still one conflict.
So, yeah, now this took less than a minute, like I said, when I ran it. So I don't know why it's doing it differently this time, but it probably just seeded itself funny. But you can see how much it's...
But I notice about this, it's all totally orthogonal.
Yeah.
Do you get to change? Do you get to change that? Because that reminds me of the old Cooper and Chan. You know, Spectra was originally basically just an orthogonal. I think the final pass it would chamfer each corner a little bit, but
right. And now it's actually cleaning up. It's found a solution for and it's doing a cleanup pass. And how many did I? Oh, it routed 100%. Oh no, it's usually 3 it leaves. There's one,
it
2.
did. It did do that cleanup, and that's where it converts from orthogonals to 90 to 45 degree corners, right?
Yeah. Yep.
So this is something. So this is an interesting note about auto routers. You can look at a board and see 45s, neat and tidy 45s everywhere, and think that the router routed it that way, and really it didn't. It found all the paths going up and down only. Right.
Right.
And then afterwards, and there's a setting in other routers I've used that do the same thing. But one router, I wish I had a license for it to play with, but I don't, is the Topper router that has kind of become a bit more popular in recent years. It was developed in Russia, and it is not restricted to 90-degree angles. It'll go any angle. And
okay.
I think simplified DA under the hood as well is another routing technology, which is outsourced to a number of different EDA vendors, I believe. But simplified DA is also a topological auto router that can go any angle. But I think the end results are always cleaned up to be 90s and 45s because users are comfortable with that.
All right. Now, somebody made a comment that it looked like trace spaghetti, but when I go into here, I actually can't route this board better than what it did. And the 3 traces it left are easy to hand route in usually about 5 minutes.
How is the signal integrity on this board? Because I know.
Oh, probably. This is a 2-layer board. I should have mentioned it's only a 2-layer board. I told it to route on.
Seriously?
And yeah, this is a 2-layer. It routed 300 traces, and it took about 2.5 minutes this time through watching the clock.
So am I seeing polygons there, which are your ground planes on the top and bottom, or are they on inner layers?
There's no power. When I deleted everything, I just told it to route the signals. Just to do this. So, for example, if this was a 4-layer board, it'd be done, right? I was actually doing this where I would hand route VCC and ground as a grid, and then let it run, and it still would perform about as good. It's just I couldn't do it in front of everybody as easy. But when you go in, you won't find any one trace that jumps to the edge of the board and comes back. Everything's pretty straightforward.
Do you have any of these modules in your lab there that you could show us, the final product?
Yeah. Hold on.
Always
Never
want to look at the final product. Yeah, it does a remarkably good job for a tool that doesn't really give you many options to configure.
Oh, right. So I don't I don't see where they're at right now, but I'll bring one for next show. I'll hold one because it actually worked. I was able to program the FPGA and I went over it with a fine tooth comb then, like you or I would normally do if we had routed it, and it was fine. There was no traces that were obnoxious. But
Right,
again,
so you mentioned this was used as a logic analyzer shield for an 18
Right.
mega. So how did you get that working? What software did you write for that or build?
Well, I never finished it as, I did the hardware to just kind of show it, but I never actually did the software or the signal conditioning that, you normally wouldn't run your signals even to a level converter without having clamp diodes and the things. And then the challenge becomes not to change the signal you're looking at through the protection circuitry. So your clamps have to be fast. You have to minimize capacitance, those kind of things.
Yeah.
So I'll pull out, I can show the schematic actually.
Reminds me of these things. This is basically
exactly. That's
an Altera FPGA with a pin header, and they reckon
right.
this one will sample at a clock up to 500 megahertz. But I don't have much faith in air wires at 500
right.
megahertz.
Oh, right. Sounds like half a gigahertz to me. Yeah.
Yeah, but it's helped me on a few projects get my logic straightened out.
I have my newest one of those, and I do know where this is. So the reason I never wrote the software is I was doing it just kind of as a project. When you can buy something like this, and this one is a Digilant.
Oh, those are really good. Yeah.
Yeah, it really is.
The digital discovery boards are really awesome. Yeah.
And here I'm set up for a 6502 header actually because I was playing with my small board computer I was making. And basically, so cool. I wanted to make sure I could see the opcodes going by and recognize them and whatnot. So when you can buy something like this, it didn't make sense for me to, and I hate programming, for me to keep pursuing the, the shield that I'd made. But you can see why the Autorouter in Proteus was so useful for a project you need to turn in a month and just, it gets 5 minutes airtime and then you chuck it in the bin. So you mentioned you might know the genesis of the Autorouter for Proteus. Do you remember where you
Proteus,
thought it came from?
I'm not sure where Proteus got their Autorouter. All I notice is that it's rectilinear. An Autorouter that does everything at first at, horizontal and vertical tends to be a shape. And then I believe a similar router, I don't know how the people, if they know each other or came from one company to another, but that kind of thing does often happen in EDA. But there's a very similar router called Electra, which is a standalone, and it'll work with any ECAD tool that can import and export. I think DSN. It was the file format developed for Spectra originally. So there's a bunch of them out there. Yeah, what I wanted to see if I could get my hands on, maybe I'll get an evaluation of it someday for us to play with on the show. But I wanted to fiddle around with Topper because it does that crazy.
Isn't it hard to get? Isn't it hard to get stuff into and out of an Autorouter if it's not built into a package? I mean, you can't take an EDIF file and have it make sense, right?
Yeah, it's harder. The problem is, you lose some data fidelity because you have to export to, say, to
DSN. Something where, the primitives don't exist or mean something else in the other package, and how do you convert?
The objects in the nets are okay. They've kind of had that down for a while. Where the gray area is your rules and your setup can be like it can do the job, but then you might need to go change a bunch of things. I remember this problem with Spectra that we used to have with customers back when, 15 years ago, where they would generate the DSN file, send it to Spectra, and Spectra would save the DSN after routing. You'd bring it back in to Protel, and all the vias would be the same size. So it wouldn't use your design rules defined via stack.
Right.
It would just put a generic default via in there, and so you had to then go select them all and replace them all with the right via, and that could be a problem because you may have different size vias for different nets. Some might be thicker for power nets and whatnot. So that used to cause some consternation, but it's little things like that can sour the taste a bit, if you have to go out to a separate program and then import and export all the time. It's always better if you can have some kind of isolation between the routing algorithm and the user, where the user doesn't have to leave the environment. That's just my opinion, but plus who wants to have to learn multiple tools? If you've got to spend your time designing things, not learning more software tools. So
right now, compared to Eagle, if I were an Eagle, and I'm not slamming Eagle much, but the Autorouter and Eagle couldn't do this. I mean, it get about 20% done and bind itself up.
Yeah, look,
back when I used Eagle.
That was a long time ago. I'm not familiar with that
it was for me.
One,
yeah.
but I can tell you the routing in Fusion is really very good, and I'm sure it's just settings, settings or rules configuration. But we have we have some of the best minds in the industry, the most experienced guys, and I can't really share any details around that. But
so yeah, the problem I had with Altium it was a simple one. I never got a good answer. I wanted to route all except power net class because it would bugger my power, as you can imagine, and it would not. It would ignore that. It would try and do the net class that I had defined as my power traces also. And I was probably just one support ticket away from fixing it, and I just did something else probably. So the Autorouter and Altium will get me 75% of the way there on a complex design. But the problem is the last 25% is really bound up, if that makes sense.
Yeah, and that's where just knowing the underlying algorithms can make a difference. And again, it comes back to that whole, the out-of-the-box settings are usually not that great. I think Proteus, they've probably invested quite a bit of R&D time into getting the out-of-the-box settings really good. And
matter of fact, I can show the settings now that I think about it. If I go to run the Autorouter again,
that's all scrunched up, though. I can't read the text.
Yeah, and I'm going to expand it and see if it's readable. That's really all the settings I have. So either it works or it doesn't. Maybe Mike knows if there's more settings or not.
That's interesting. He's still using it. There's really not much there. That's what I'm saying. Like, there's a whole lot more behind it in terms of settings.
Oh, yeah.
It's either hidden from the user or it's able to infer those things based on your design rules, which it should. A good Autorouter should do that. And you can do that if it's built into your EDA tool, but if it's a separate tool, it can't, because it just can't get that information out of the database. So, yeah, so we should do some notes comparing, but
yeah, let's do other Autorouters in the future. I just thought I'd throw the glove down. And again, I look like a smack ass because I say it'll take 1 minute and it took 3, but it still went pretty quick this time. And now I am curious as to why it was different when I went to show you because I timed it at exactly 1 minute previously. And you could tell it was a lot more confused this time with where it was dropping the vias and stuff.
Something must have been changed in the meantime.
Some random number seed or something.
I want to ask you something important, though. Is there any way you can get that board out of Proteus?
No, not at all. That's why I had to stop using Proteus.
No import export, huh?
None to speak of. So I went to Altium.
They have a scripting system that you could write a script to basically generate.
Not that I recall.
Yeah. So
you've
got to use an EDA tool that at least has a scripting engine and preferably.
Well, this is a $500 tool. That's the difference here. Is Proteus only costs $500, and it's not doesn't limit your board size and things like Eagle did for that.
I thought for the full Proteus it's more like 6,000. You should check that.
Mine's the one you just saw is $500.
Okay, yeah, but I'm sure that's limited in size.
Hey, Mike, what did you pay for your Proteus? So we'll see if Mike, because Mike just happened to ask me about something that was cheaper than the high-end stuff, and I told him Proteus, and he's actually been using it. He's better at it than I am.
Fusion.
I couldn't even remember how to pan it.
I gotta say, Fusion.
So Mike says $250 for entry level, $1,000 for the main stuff. So the price has doubled in the last 4 years.
Yeah.
So that's still pretty good.
Or for $500 you get Fusion and the full Eagle, and that means you get all your mechanical modeling, the ability to create proper native 3D part models, and in the library wizard, the package generator. So anyway,
Mike says you're right. It's 6,000 for enterprise.
That's right. I'm saying.
So, yeah. Now, when I say for the entry level, when I was like 400 for me, that gave me like 2,000 pins. So they didn't limit the board size.
So
they limited the number of pins.
Yeah.
Yes.
2,000's pretty generous, but I tell you what, if you're doing any kind of even a retro computer with an 8-bit CPU and chips and glue logic, you're going to get to 2,000 pretty quick.
Yeah. So, hey, you wanted to talk about Oshpark. You wanted to give them a shout out. You have a new board from them.
These guys are so nice, Oshpark, and I would think, their really main focus is serving American customers, but they ought to see if they could set up a factory overseas for Europe too. But these guys, so some weeks ago I was talking about my my Octave Up, and I'd sent that off to get made for Oshpark, and I was promising a demo and everything, and then what happened was their address for me in the system was still set to my old office address, which I no longer go to because I no longer work there. And they sent the boards there, and I got in touch with the office manager and admin staff, and they're like, no, we haven't seen your packages and everything. So I went back to Oshpark and I said, well, I guess I'm going to have to reorder them. And I was talking to Chris, and he said, I'll tell you what, don't worry, we'll just send you more. And we'll go even one better. We'll put them on the urgent panel tonight. So these guys are just so super nice and helpful. So I actually got them. I haven't quite had time to put them together. I was hoping to do that for today's show so you could all hear what it sounds like. But maybe next week, hopefully I'll have these, at least one of these fully assembled. But they're amazing. And already got them. I did notice I did one faux pas with one of the components. I
usually make one mistake per board.
This footprint, which you can see the outline there. I'm not sure if I can get my camera to focus properly on that.
Yeah, back it up a little bit.
That's for.
There it is.
Yeah. So my middle finger is just over that. So that's
at least you have one. Yeah.
That's for a push. That's for a push switch. And you see how tiny the pads are?
Right.
Now, as far as I was making the footprint, I made it exactly according to what was written on the data sheet by Alps Alpine, the manufacturer of the switch. And now I realize lining a switch up to this, I thought those look far too small to be the pins of a mechanical switch. And sure enough, they are. And the problem is the pad diameter, the hole diameter, is set to the width of the metal pins, but the metal pins are thin in one direction but thick in another. So I'm going to have to. I can't drill those out. That probably will cause a short.
Void your warranty. Yeah.
But I'll figure out some way of attaching the switches. I don't know. Maybe I'll file down the pins to make them fit in the holes for the prototype. So annoying. But well, always do something stupid like that.
You know what I used to do more often than I do now, and that's because of the 3D viewers, is I wouldn't leave enough clearance around things like connectors or any object that had, was tall or wide or big. I would scrunch parts up on them without visualizing the connector correctly or the switch. And once I went to 3D, I'm like, oh, let's clear the parts away from around the switch or whatnot a little bit more, because they simply wouldn't fit in real life,
Yeah.
So hey, you talked about. Go ahead.
Oh no, I was going to say my original design. So these came out purple because they put them on the rush panel, but they're also sending me a set that's to my original spec, which is to use their After Dark service. So
that's what I was going to ask you. Okay, there you go.
This. So this is a transline PCB ruler, and this one has a blue substrate with clear solder mask over the copper. So
which I have never seen clear personally. Yeah.
Yep. And the blue substrate under it. It just looks awesome. So Oshpark are doing this, but their After Dark is with a black substrate. So I'm looking forward to those. They're going to look sick. I think I can't help it, but on one hand I'm saying auto routers can be useful and I don't care what it looks like as long as it works. Yeah, it's true. But also if I can make an analog sort of guitar pedal type project and the PCB itself looks awesome, maybe no one else will ever see it, but I'll just, the thought of it's nice to me.
I'm actually checking JLPCB to see if they still have just the regular colors of solder mask, and yeah, they don't have clear yet. That's cool. Well, I'll have to, that's the kind of thing, like if I was still doing a lot of Hackaday boards, I would go to Oshpark, which Hackaday loves Oshpark anyways, just to have the clear, just to have something cool when I'm holding it up. That'd be excellent.
There's a practical side to that too. If you're only doing 2-layer boards, being able to see through and see clearly all the traces can be a useful debug feature.
Somebody just asked how Oshpark's lead time is.
Well, for me here in the States, I usually, from ordering from California, they're based up in Oregon. I normally get my boards, in 10, usually about 10 days, 10 to 14 days,
right,
including weekends. So they're pretty quick. And
apparently, Proteus has made some changes. Mike posted, for $1,000 you get 1,000 pins. So it's not near as cheap as it was when I started. So I'll go ahead and throw myself on my sword on that one, that they got greedy since I used them.
I thought the big advantage for Proteus was that you could co-simulate everything. Is that still?
Yes, you can. So I paid an extra couple $100 for built-in simulation, and you can even simulate software for the PIC and for the AVR series and stuff. And do the whole simulation where the LEDs appear to light and stuff on the schematic.
It always looked more like a toy or sort of educational tool to me, but I guess it has some practical.
At the time, my only alternative was Eagle, so I loved it compared to Eagle. And there were a few.
Slamming Eagle, Bill. Come on.
I was just getting ready to say there were just a few things about Eagle that irritated me, and it was because it acted like a CLI program somebody had slapped a bad GUI on, and come to find out that Eagle really was a CLI program that somebody slapped a GUI on. So, it was kind of, my complaints were based in real life, I'd like to think.
Well, Fusion's getting it. a lot nicer. One of the cool things about putting EDA into Fusion is that we get to renormalize all the user interface paradigms. So if you're building a part model in 3D, it's pretty straightforward. You start from a sketch, you extrude things, you do, and there's a wizard to automatically build the parts too if you want, but it's really easy. It's just super easy to drive. But we have a dedicated XD guy just for electronics now, so we're working through refactoring all the workflows to make them a lot smoother and better. But the command line is still there, because this is something people used to bitterly complain about when I was at Altium's tech support, and users would previously come from Cadence Allegro, and their company decided to move to Altium. The PCB designers would bitterly complain that there was no command line, because they had built up a library of actions that they'd saved in a text editor, and they could copy and paste them. Mentor Board Station did the same thing. And this is something Eagle did have, that as a new user, it felt difficult to be productive. But after you learned how the CLI actually worked, and you could create these script SCR files, and I've seen some expert users who have a library of that stuff. I've watched them work, and they're insanely productive, and they can do crazy things that I didn't think were possible. So it's a two-edged sword, but really there needs to be more exposure in the UI to some of that goodness too. So
Right.
So I would have said exactly the same thing as you, a year ago, but now I've seen the other side a bit more, and I'm still learning. I've got a long way to go, but but there is definitely some value in there. So anyway, what are we looking at there? It looks like a stereo tube amp.
This is a stereo tube amp. It happens to be the schematic for a Macintosh, and so I found this, and it was hard to find one that was legible, but they all look very similar to this, and you kind of started dissecting it when I showed it to you right off the bat. You want to tell us what you see when you look at this?
Yeah, well, I see two identical channels, so definitely stereo. So let's just look at the top one.
Right.
So the first stage, that half 12AX7 on the first stage, is just a basic common emitter
preamp
inverting amp for some gain. It's got some cathode feedback there. That's the two resistors underneath.
And that's the first thing I saw was coming from this transformer,
so it has
all the way back to here. It has negative feedback.
Yeah, for the whole channel. And then that goes to the second stage, the V2 stage, and this comes back to our conversation last week. That's a diff amp. That's a long tail pair, but it doesn't look like it because this is how they used to draw them.
Right. And they shared this one resistor here in the off the cathodes. Yeah,
so in a two transistor diff amp, that would be an emitter resistor going to ground, and then the two collectors would be the plates or anodes here are like the collectors in a diff pair or long tail pair. And that drives a second stage long tail pair again. So it's a diff amp going into another diff amp, which gives the push-pull outputs you need for the power amp stage, which is that final, they look like pentodes. No.
Yeah, they're probably beam power pentodes. They're 7591s.
Right, so pentodes are almost always used in output stages.
Right, for linearity, right?
Yep. And bias, additional bias control and all sorts of...
Yeah, the one grid that sends the electrons that bounce off the anode, it sends them back to the anode. So, I've often said with Macintosh, you know how Harley Davidson, the title for the motorcycle actually travels with the engine block, not the frame. And I would say with Macintosh that it was always the transformer is where the money is. and that the title for your Macitosh amp should be travel with the transformer, not the chassis.
I agree.
But
they actually had a really cool YouTube video I saw some time ago where they show how the whole
making
Macitosh
one or
amplifier is put together, and they showed the actual stage of there was a woman sitting at a winding machine. She's winding like all those output transformers. She's winding them on the machine, like eight of them at once, all stacked up, all the bobbins stacked up, and she's just sort of running the machine, making sure everything works properly and doesn't get tangled up.
Now, have you ever used a stereo tube amplifier for your main music source? Not counting your guitar work.
I'm trying to remember. No, I did have a stereo high fidelity tube amplifier, but I used it as a guitar amp. Because
you can't blow them out. First off, I knew guys that would plug their guitars into a solid state amp and then blow the outputs.
Yeah, and I wish I still had it. I'd have fixed it all up and kept it for stereo purposes. It was about 20 watts per channel,
which was a lot back then if it was clean.
Yeah, that's right. That's right. So, but I was using it. My big brother, who was an electronics tech, who got it for me, I don't know where he found it, but he gave it to me. He paralleled up the outputs to drive a guitar speaker and made a guitar input on it. And he said, you always have to turn, it had coaxial concentric controls for the two channels for tone and volume and preamp gain. And he said, you always have to turn both the knobs together because there's two amps in parallel here. And it'll work. Right. It'll work. And it did work. And it sounded awesome. It sounded really good. But then one day I let a friend of mine plug his guitar into it and try it out because he was real curious about it. And I was like, yeah, you can have a turn. And then he cranked the volume right up to 10 because he just wanted to go loud and see how loud it would go. And next thing you know, smoke was pouring out the back of it and the thing was toasted. And I'm like, dude, come on.
Yeah.
Really?
Yeah, it's such a solid signal. Yeah.
Yeah. But I think it was
somebody asked why
it was the parallel channels. I don't know how they were paralleled exactly. I don't know what my brother did to it, but something in there, some currents got out of balance and it threw the whole thing out when he cranked it right up. It just killed it.
Now, somebody just asked if tube amplifiers always had transformers, and to me the answer is yes. First off, because the voltage on this plate is 390 volts here. So they not only convert impedance, they're converting voltage in a way that, nowadays you can take your power supply right across the speakers depending on how many watts you need, whether it's 40 volts or whatnot. But this is 300 volts on the plates of these output tubes.
Yeah, tubes are inherently high impedance devices.
Right.
So they have a high output impedance. And that means they have to operate at high voltages, low currents, which means you have to have a transformer to drive an 8 or 4 or 16 ohm speaker.
Right. Now, I have
seen headphone amps made with tubes that normally have a transformer as well, but there are some designs that
if you're throwing power away, you can use resistors and whatnot.
Yeah.
But you're throwing the power away by doing that. And with a headphone amp, you want to throw away power, because you don't want to blow your eardrums out.
Right.
So now I had a Fisher back when I was young, in my high school days, and it used the old 6BQ5A tubes and it had the you see the ion emission on it, pulsing to the music, and that was part of. There was no case on it. Just knobs with no labels and a chassis with tubes. And you would sit there and watch it like you would your fireplace. You would watch the tubes pulsing to the music. And I still have my speakers from them.
On it too.
You warm the whole room on it. It's absolutely. And big ass transformers, and big ass capacitors.
You can still buy all that stuff. It's just most of the tubes are hard to get now, but thanks to the guitar industry and high-end audio like Macitosh, a few specific tube types that are specifically good for audio are still widely available, still manufactured. They just cost a lot, and the transformers cost a lot too because there's a lot of metal in them. But you can buy tube matching impedance matching transformers. You can buy cathode chokes that help smooth out your power supply. You can buy all sorts of stuff from companies like Hammond. They have it.
Right.
There's a lot of open source. Pretty much all tube amps are open source anyway. Back then they had to publish the schematics so you could service them. Which
you could service yourself because you could buy tubes and even test them at the local drugstore. Here's the cathode choke you're talking about, and again, that's probably a custom wound thing, being that this is a Macitosh.
And it looks like they pick off some of the signal from those too. Where does that go?
There's taps here, and I don't know where the taps go. I couldn't find them before the show started. These taps right here on the, but and part of what these chokes do, is to keep this voltage here from jumping around. It regulates the cathode voltage, given that you are sticking some feedback into the cathodes.
Yeah.
So hang on, let me get him back up. So yeah, I just, I priced out like a Fisher like I used to have as a kid. They're like $400 or $500 on eBay now, and you can get tubes for like $25 to $40, on the internet.
If you don't mind designing, just using run-of-the-mill 12AX7s, which are utterly fantastic.
They're clean.
You can use 12AX7s for preamp and bass grid drive, like the first, second, and third stages you see here. All 12AX7s or 12AT7s or U7s, they're all pretty good for that. And then you can use EL84s or EL34s or KT88s. They're a little more pricey, but they make good outputs, and you can buy the transformers. If you really want a good tube amp, there's no reason you can't just build one.
You're actually making me want to build one, and I'm kind of not building a lot of things these days, but it's kind of reminiscing about tubes.
You can even buy.
Yeah, where do you get sockets? Where do you get the capacitors?
You can buy all that stuff. Just go to AliExpress. There's a lot of companies.
Do they still have the 300 and 400 volt cans, capacitor cans, as we used to call them? Do they?
You can buy high voltage caps. That's no problem.
Well, but not like we could in the old days where you went to Radio Shack or just out of Allied. There was huge number of them.
You'd have to get them from a distributor and order them online.
Right. Now the 12AX7, I think that I used to be a TV repairman back when I was like 17. Actually got licensed for it. And I believe the 12AX7s were good enough they used for the intermediate frequency amplifiers of the day. So even though we talk about them in audio, I was first ran into them up at 4.5 megahertz.
Really? So I didn't know what their transition frequency was, but
don't quote me on that, but that's my memory. Yeah.
Yeah. Most, it's just like discrete transistors. Most of them, maybe you see them a lot in audio, but most of them have a pretty high transition frequency. You're certainly not going to do 2 gigahertz with them. You need, for anything over 100 megahertz, you really need proper RF dedicated devices. But a lot of
those tend to be triodes versus pentodes. As you might think, adding all that extra metal in there adds capacitances and couplings and So a pentode, I don't recall seeing pentodes in the IF path, as often. So, well, hey, look at the clock. Guess what time it is?
Wow. Seriously? Where does it go?
Yeah. It went good. I love talking about tubes. I'm too old to start collecting tube stuff, but it makes me want to do it.
Well, there's you know, the tube project that helps get the bug out of the system but doesn't suck you away for too many days is a headphone amp.
I knew you were going to say that. That's
Or
yeah.
a preamp. Maybe just a basic preamp with tone control. But do a headphone amp. And for the output transformer for a headphone amp, I've seen another trick. You can use those little PCB mount power transformers. They're like maybe a 2 or 3 watt transformer that's normally taking line voltage like 110 or 240, depending which current country you're in, and spitting out 9 volts. But if you think about your impedances, a transformer, an off-the-shelf power transformer with the right voltage ratios can be used if the right voltage ratios are the inverse or close enough to the inverse of your impedance ratios. So
right.
So you could take
now.
Yeah.
Go ahead.
So you could use 2 little PCB mount transformers for your output drive to the headphones.
Okay. And I was going to say the project I did as out of Popular Electronics, actually, way back when, don't laugh, was a turntable amplifier. Remember turntables? I think they're still around, but
yeah. So that would have been with RIAA equalization.
Yeah. Yep. Yeah. I had a switch for two different modes. Yeah.
Get rid of the rumble and give you a bit more.
And those were definitely triodes, and I don't know that I ever used it a bunch, but it was like one of those little projects, because they didn't have a lot of transistor. It's not like today where we went through a phase before there was phono inputs on your amplifiers. You had to have a phonograph turntable amplifier. And then for a while, stereos had built-in turntable amplifiers. And now, once we're back to no turntable amps, because who's got a turntable?
Yeah, or really expensive gear because it's really audio.
Or the fancy stuff.
Yeah, like you can buy a turntable, but it's machined out of granite.
Yeah, and floats on magnets or something like that. Yeah.
Yeah, crazy stuff. Yeah, really nice, but just out of my reach.
Well, I remember they tried the same thing with the early device called a CD, right? When CDs first came out, and they were like, ooh, ×4 oversample. And they went through a phase where it's, ooh, a belt-driven CD player. I don't need a belt-driven CD player. It's digital to begin with,
I know.
But they did have them. Yep.
Yeah.
Well, my friend, I think we've come to the end of another show. This was fun.
It was.
This was fun. I'm glad I found the Macitosh schematic.
We should do this again. And next time I'm just so people can see. I showed you this before, but I'm just finally starting to get sort of set up at my desk here with a few things. So I'm hoping that we can actually I don't know, fiddle around with
do some bench stuff. Yeah. I saw a keyboard there as you panned around too. So there's all kinds of good signal sources.
Yeah, it's just sitting over there. That's just a MIDI controller, but yeah, it's supposed to be hooked up to the computer for making music.
Right.
Supposed to be.
we should mention we have a Discord channel. I don't know how to find it. I was going to show a QR code for Discord and actually put it on the screen, but a little bit of Googling and people are turned off of QR because somebody was doing malware for Discord logins using QR codes. So I'm not going to do that. But for those that are on the Discord channel, if you got topics for next week, by all means, drop them there. There's a channel for that. What's the easiest way to find the Discord channel is to go to Coriolis-effect.com. That hyphen is a dash. Do not spell hyphen. I've had to say that a couple of times for other domains. But we'd love to hear about topics that you have. So
yeah, there's I'm just generating a link here, Bill. I don't know if there's a way of I'm going to put this up on the screen. Let's see how I can do this. I'll just create a Word doc. Sorry, it's a bit slow. Okay, that was a dumb idea. I should have just opened a generic text editor, but whatever. I'll make it really big, so
So how are you going to get it on the screen? Do you need a screen share or?
Yeah, just give me a second.
I think I have screen share set up.
I
For
can.
you.
Where is it?
Or we could do it next time.
Oh, you're looking at my other screen there.
Yeah, I just brought it from last week. Yeah.
Oh, okay. This should be sharing. It ain't working though.
It's unshare and reshare. We found out you had to do that one time.
Let's go full screen.
Yeah, not working.
Oh well.
Well, we'll figure out a good way to turn people onto our Discord.
Yep.
We'll tweet it or something.
Yeah,
So,
but you can
all
just
right,
go
my
to
friend.
Discord GG, discord.gg, and then search for Coriolis, Coriolis effect, and you'll find it.
Yeah. Yep. So very cool.
Yeah.
So we'll see everybody next week, and we'll
Yep.
see you again next week, Ben. And
Yep. Good to see you, man.
we'll click end stream.